is always our enemy. It's just, it is the way it is, right? We have so much to cover and so little time to do it, it feels. We're going to look at a topic called average value of a function.
Is that 6.5?
Yeah. Now, I know we're doing 6.4, but I want to do 6.5 first. And that way I'll know exactly how much time I've got to do 6.4. 6.5, in my opinion, hopefully you'll agree with me, is relatively straightforward. So once you've seen 2 or 3 examples of 6.5, you pretty much know how to do all of them. So let's give you an example of what we're after, what we mean by the average value of a function. Well, imagine I have a function, it starts off here at x equals a, and it does whatever it does, and it finishes up here at x equals b. That shows you how much I've been writing. I've run out of ink on my pen. So I'll get a replacement. Do I have a replacement? That's not cool. Okay, got one. This is the function y equals f of x. It starts at a, it finishes at b. And we are after what's called the average value of the function. So I want you to just imagine that I was trying to find the average height, which is what the average value of the function is. And so the height would be, you know, like that distance there, for instance, right? Now, one way to get the average would be to find all of these heights, all of these y values. And normally to get the average, don't you basically add them up and divide by how many there were, right? That's how you get averages, everything. So if I did 100 of these, I would add up the 100 heights and divide by 100. But couldn't I do 1,000,000 values or 1,000,000,000,000 values or an infinite number of values? And what you get then is this formula, that the average value of a function is 1 over b minus a, the integral from a to b of the function dx. And the good news is that's the only function formula that you need. You know, like when you do rotate about x and y and different techniques, there are all sorts of fiddly things you have to adjust. There are no adjustments. From a to b, this is the average value. Now, if you think about where's that coming from, isn't this kind of what you'd get if you had an infinite number of lines? And then you divide by that distance and that averages it out. So what this generates is a number, and it would generate a number something like this number about here. So the average height of the function, the average y value, is this guy. So all you really need is give me a function and tell me where to start and finish, and I will be able to, or you will be able to, get the average value. So here's my first example. Suppose I wanted to do x cubed. And I want to find its average value from 0 to 2. So the average value, let me show you some new notation. F av, so it's not fav, it's f, the average of, average function. It's 1 over b take away a, the integral from a to b, of whatever f of x is, dx. So in this case, a to b is 2 to 0. The integral from 2 to 0 of x cubed dx. Now, to me, I hope, hopefully eventually to you as well, isn't this a plug and chug question? You just plug in numbers here and you do a bit of integration and you're done. And if you think of it that way, you're going to find that's a good thought process, because it stops you getting too caught up in the, you know, the picture and the lines and all that stuff. Because basically this is going to do the gist of what we want. So I've got a half. This fella here is basically a power rule. Are we comfortable about the antiderivative and why it's what it is? Add 1 to the power, divide by new power. If I then plug in 2, I'm going to get that, take away nothing. 2, 4, cancel off 2, 4, I get 4. And so the average value is 2. So if you took the function y equals x cubed, which looks something like that, and you went from 0 to 2, which is basically here, right? The average height of that function, the average value, is 2, which is about there. Yeah, it seems about right. You know it's not 4. You know the function starts off at 0 and it reaches a top height of 4, but the average height isn't 4. And the reason for that is, doesn't it spend a lot of its time being quite low, and then it really only curves up at the end? So most of the low values are happening, and that has reduced the overall net effect. So yeah, it works. Is that a nice, easy one to get your teeth into the process? Average value function. Right. Let's look at let's do the average value of a cube root of x. So the average value of the function is going to be 1 over b minus a. The integral from 0 to 8. The function dx. Well, that's going to be 8 take away nothing, so I'm going to get an 8th. Okay, this is processed now. I need to integrate the cube root of x, but that's really not the form that it needs to be written in order me to get antiderivatives, agreed? So what shall I rewrite the cube root of x as so I can, continue with this process?
1/3 x.
Is that what you mean? Yeah. Fractional power. Now be careful. Add 1 to the power. 4/3. Divide by the new power. 3/4. Evaluated at x equals 0 to x equals 8. And then remember, this 1/8 is still there, right? The 1 over b minus 8 is still there. I would convert that. So what am I going to get? I'm going to get 3/4 the cube root of x to the 4. Well, the cube root of x to the 4 is the same thing as the 4th power of x cubed. So it's 2 to the power of 4, which makes it 16. Take away nothing. That's 1/8 times 12. That's 12/8. That's 3/2. So the average value would be 3/2. Now you notice no decimals, no 1.5s, 0.707s. Exact values every time. Are you comfortable about this answer is 16? Do you know you could just plug into your calculator, couldn't you? And you'd get that. And the reason why it's good to do it this way is that sometimes it won't be perfect. It will be 4 root cube root of 3, right? Square roots especially, Square root of 20 should be 2 root 5 and so on. Are we cool with that one? Okay. The guys I'm doing are very similar to homework questions. I'm just not, because I forgot to. writing down what the numbers are. So this one that I'm doing right now is similar to 4. The function that we're going to do it to is t over the square root of 9 plus t squared. And t is going to go from 4 to 9. So the average value of the function, 1 over b minus a, the integral from 4 to 9 of this guy, dt. Okay, we need a technique. What method am I going to use to integrate that fella?
U sub.
Right. U subs never go away. You might not see them for 2 or 3 days, but they are going to keep coming back all the way to the, the 11th week and beyond. So in this case, it is a U sub. Who is the U sub?
The whole bottom?
And if it wasn't the whole bottom, what would be the alternate choice?
9
9.
plus t squared.
Right, now I've given you the 2. Do you see why that one's a better choice in this particular situation? Agreed? I'm using the rule ugly guy inside square root is your candidate for the U sub. Right. Now, if you differentiate with respect to t, you get 2t. You then do the crossover. And then you isolate the dt. What happened to that guy? He's a t. There you go. And you isolate the dt. So we have the integral of t over the square root of u times 1 over 2t du. The t's cancel. That basically is a half. I'm going to pull it outside and call it a 10th. And that means that we're now dealing with that situation, right? Are you comfortable with that 2 comes out and makes us a 10? Okay, I have a different problem. I need to find this guy's antiderivative. I need to rewrite him as a fractional power. What fractional power is 1 over the square root of u going to get you?
Negative 1/2.
We're all comfortable with that? I'll add 1 to the power and then divide by the half. Isn't dividing by half the same as multiplying by 2? I'll pull out that 2, which now means I've got a 5th, and I'm left with u to the half, which I am going to convert into 9 plus t squared to the half, and I'm going to evaluate it at t equals 4 and t equals 9. But I don't like fractional powers, especially when I have to put numbers inside them. So this is now converted, what I call style points, into the original form. Now let's see what we get then. If you plug in 9, you get 9 nines is 81. 81 plus 9 is 90. So I get the square root of 90. Take away, if you plug in 4, you get 16. 9 plus 16 is 25. Do you think I'm finished? Is that as good as that answer can be?
No.
No. In fact, can't both of them be fixed? That one's the easy fix, isn't it? A nice number. But what about the square root of 90? Can it also be fixed? Yeah. 3 times. Right. 9 times 10, which becomes 3 times root 10. And that's your average value. So you could have power rules, you know, find the average value of a polynomial, right? X cubed plus x squared, right? We've done things like that. Find the average value of, you know, the cube root of x. Here we're looking at a situation that involves a u sub. Next one I'm going to do is trig. In fact, I'm going to do a couple of trig. Here's my first trig. Okay, now average value. Basically 1 over that. The integral from 0 to pi upon 2. Sine cubed cosine dx. All right, I need to integrate this guy. This guy is not pretty. This guy does not have, it's just not doable the way it's written. What technique am I going to use again to solve this one?
U sub.
And now we have a decision. Always with U subs, you have the same decision. Who's the U sub going to be? Well, before you tell me that answer, I'll give you some choices. Couldn't it be sine x? Couldn't it be cosine x? Or couldn't it be sine cubed x? Would you agree that's probably the 3 reasonably realistic choices? But only one of them actually works. Only one of those U subs does the job. I'll take a volunteer. What one?
Sin x.
I hear sine x. Arvin, were you going to choose sine x? Okay, so here's your problem. Tell me why. What made you pick that?
Because then the sine cubed will become u cubed, and then the sine will become 1 over cosine, which will cancel out the cosine we have.
Right. So once you get used to U subs, isn't that the kind of thing you do in your brain? Oh, that's going to turn into this, and that's going to cancel out that. Good U sub. Right. So I like the way you said it as well. So differentiate a sine gets your cosine. Swing it back round and isolate. So sine cubed becomes u cubed. Cosine x, 1 over cosine x du. Here's a little algebra. 1 over pi over 2. Yikes. Nobody likes that. You're not going to leave it, right? What can that be rewritten as? 1 over pi over 2 is the same thing as what single fraction?
2 over pi.
Isn't it basically reciprocal? Right. I hope you agree. Isn't that much prettier looking than that? Right, just visually. Right, now, we're going to do an integral of u cubed du. Perfect. Power rule. Return back and plug in x equals 0 and x equals pi upon 2. Okay, Sine of pi upon 2 is 1. 1 to the 4 is still 1. A quarter times 1 is a quarter. And the other guy is 0. That partially cancels. The average value of that function is 1 over 2 pi. Does that have a nice flow to it? This process, plug and chug. Agreed? Now, is it possible, because I know this is going to happen, so I guess I've told you the answer. How is it possible that the average value of a function could end up being 0? How could that ever happen, that the average value of a function is actually 0?
Symmetrical.
It's
Some kind of symmetry, I agree. For instance, if I did this function, which is the sine function, won't this bit be totally cancelled out with that bit? And so wouldn't the average be 0? Is it possible for the average value of a function to be a negative number? Great.
Yes.
Visually, how would you get that? That would be an average of 0. What would a negative kind of look like? What kind of curve would give you a negative average value?
a curve that's mostly below the x-axis.
I like your way of saying it. Can you imagine this curve where more of it is below and just maybe a little bit's above, or all of it is below? That could happen. So when you're doing these questions, don't freak out if one of the answers is 0, and don't freak out if one of the answers is negative pi. If you've done the method correct, it could be 0 sometimes, and it could be negative something like pi in other situations. Totally okay. Nothing wrong with that. On the other hand, if you did a volume question and you got 0, should you be worried?
Yeah.
Yeah. If you got a volume question and you get a negative answer, should you be worried?
Deeply worried.
Right. If you're doing the area under a curve of a single function, right, just an f of x, is it okay to get a 0 for the area under a curve?
Yeah.
Yeah. Actually, the question we just did a minute ago,
Yeah.
although this is an
because-
average value, that would be 0, and wouldn't this be negative?
Right.
But what about the area between two curves, right? An f of x, take away g of x. Is that ever going to be 0 if you do it correctly?
No, not unless you're in some sort of weird alternate universe.
Right, and we're not going there, right? And negative is a no-no. Now, why am I going through that? It's helpful if you know context. It's okay to be negative, fine. If it's not okay to be negative and you see a negative answer, shouldn't that be, okay, let's take a deep breath. I'm going to go through that question a second time and figure out what the heck I did wrong, because I know I must have done something wrong. It's not a very big check, but you know, every check that you can do is helpful. Let's move on then. I won't do all of this question. I'll basically just do the setup and leave it. And this one is like question 7. Now, to get the average value of this function, it's going to be almost a carbon copy of the fraction get. And this bit's pretty much the same. What method am I going to use to find this integral?
U sub.
Yeah. And who is the u sub going to be?
Cosine of t.
And can you trust me that it kind of does what it does and you'll get a nice answer. Here's another one. This is like 10. Well, the average value is 5 take away 1. And I'm going to actually go through this one, not just, start it and leave it. I need to find the integral. Log u over u. Agreed? How am I going to do this integral? What method?
Would you do a substitution?
Yeah, I'm glad you said the word substitution instead of u sub. And it's just an annoyance. But since this variable is called u, I can't really do a u sub. So since I can't do a u sub, I'm going to do a w sub. Because I just decided I like that letter. What will w be equal to? What will my substitution be equal to? And this is kind of sneaky because it doesn't obey the usual rules. This is, an exception to the usual rules.
ln of u?
Yes. Now, differentiate with respect to u, and you get 1 over u. If you do the old cross multiply, and do you see that you actually get the answer in 3 lines instead of the typical 4? Haven't I already isolated the du? So the average value of this function is 1/4 the integral of w over u times u dw, which is 1/4 a very nice integral. It's in fact going to be 1/4 a half w squared, which is now going to become 1/2 the natural log of u squared, evaluated at u equals 1 and finishes at u equals 5. Are we comfortable with how far we've gone? Are you okay with the steps? Everything makes sense? Okay. If you plug in 5, you get 1/2 the log of 5 squared. Take away 1/2 the natural log of 1 squared. Okay, let's try and make things pretty here. What number is the natural log of 1? Natural
0,
log
right?
of, right. So won't that just become a big fat 0?
Yeah.
And so now I have 1/4 a half of this guy, which I'm going to call 1/8 the natural log of 5 squared. And that's actually as good as that's going to get. It's not 2 log 5 if you were thinking about that. The log of 5 squared is 2 log 5. But the log of 5 all being squared isn't changeable, right? That's as good as it's going to ever get. And remember, we're always looking for exact values. So don't tell me that's nothing 0.1234 because that's what the calculator said. It's not going to work, right? We don't want that, which does very often add to your workload, unfortunately. We good? Right. So far anyway, has an average value of a function been a plug and chug situation? Right? Here's a function, here's the start and finish value, your A and B. Plug them in, and you got an integration to do. Could be a trig U sub, could be a U sub, could just be a power rule, could be a fractional power. Off you go, do your stuff. So what is left then is this puzzle. Imagine that we did the average value of a function in the usual way. So some function f of x, and it started at A, and it finished at B. And I found the average value of the function. And let's just say it's 42, because I like 42. Now, if I go and I plug in 42, let's say it's there. If you go and do a horizontal dotted line here, would you agree that there is at least one point on the function that's going to have the property, and let's call this function, this value C, isn't there going to be one number C that has the property that it's equal to the average value? At least one.
Yes.
Now, probably my picture that should be a bit higher, but the gist of what I said is still true, right? So what we're going to do in this new group of questions is we are going to find the average value, right? We're going to find this number 42, whatever it really is. And then the second half is we're going to go hunting for the C's, right? The X coordinate equal to C that has the value at that point. So I'm looking for places where the function is equal to 42, essentially, right? So what values of X is the function 42? So let's just make our own. Don't make my life, and therefore your life, too hard. Can someone give me a nice, easy polynomial to work with? Nothing too weird, nothing too big. Make it easier. A single power of X. Let's just do a single power of X. I'll write it down.
X to the third.
Okay. Do you want a number in front? I'll allow a number. Do you want 2x cubed, 3x cubed, something like that?
5.
Okay. And I'm going to take over the 0 to 2, right? So I decided that we are going to find the average value of this function from 0 to 2. That's nothing new, right? We've done that before, so we'll get through that pretty quickly, I hope. The average value of the function then is going to be 1 over 2 take away 0, the integral from 0 to 2 of the function. So that's going to be a half. Add 1 to the power and divide by the new power. And evaluate that at 0 and at 2. So let's see what we get. 2, 4, 2 more 4s, that's 20. 20 take away nothing. Oh, I really like this choice. We got a really, really nice average value, because it could have been 17 thirds, right? It could have been really messy, but it wasn't. It's a nice number. I like 10. So what we're going to do now is, can you imagine that 5x cubed looked like this? And that was 0, and this was 2. And we've just found out that the average value is 10. I'm trying to find that guy, which we call C. To find him, you solve when is the original function equal to the average value? When is the original function equal to 10? So we have to solve when is that guy equal to 10? Okay, as long as you do it to both sides, it's okay rule. I love that rule. It's my made up name for it, but you know what I'm getting at. What should I do to both sides to get closer to finding X?
Divide by 5.
And I like the person who picked this because guess what? It's a nice number. I like nice numbers. Well, tell me who X is. What do I need to do to both sides?
The cubed root of 2.
So you will be doing in your funny little box, C equals the cube root of 2, which means that guy there is the cube root of 2. Now I know what the cube root of 2 is. It's probably about 1.3. I guess I should find out. So cube root of 3, what does that look like? It's 1.26. We don't want to know that. I'm just telling you. But doesn't 1.26 seem reasonable based on the start and finish value? And so what you're doing is icing on the cake is not only you're going to find the average value in some of the later questions, you're also going to have to find at least the 1 point on this particular curve where that happens. Now, there could be 2 points. Can you imagine a curve that went up and down like a sine curve? Couldn't you have an answer at the beginning and 2? In which case, I know this doesn't, but can we pretend that negative the cube root of 2 worked as well? That would be the 2 answers that we would give. So you give all valid answers. Suppose it was a x squared curve. And I got to x squared was 4. Then technically, couldn't x be plus or minus 2? So imagine that was 0 and that was 4. But in this case, don't you only pick 2? Because shouldn't the c be in the range of the function? So if you only did the average value from 0 to 4, you only pick solutions from 0 to 4. If you're doing a trig question, you know there's an infinite number of answers, but aren't you only interested in the 1 or 2 answers that are in the interval that the question was dealing with? I'm
Can we
getting
do
good
one of
vibe.
those?
Say again?
Can we do a trig one?
Sure, why not? Let me find one of theirs. Ooh, that's a good one. Okay, this is question 13. Yeah, see, they like 42 as well. Does anybody know why I like 42? What's the significance of that number? Because it does have a significance.
Is it that it's the answer to life, the universe, and everything?
Yes, it is. Who said that?
Hey, Megan.
Oh, I couldn't see. I don't get to see all of you in the screen. Yeah, so Hitchhiker's Guide to the Galaxy. 42 is the answer to everything. All we need to do is figure out what the question is and we're good to go. So, can you see that this is an ugly version of our typical question? Now, it says that it's got a written part to it. This is from 9 a.m. to 9 p.m. And so the average temperature from 9 a.m. to 9 p.m. and round off your answer in nearest whole numbers. Ooh. Okay, so that's going to be a decimal question. Can we keep that one till tomorrow? And just remind me to do 13 tomorrow and I shall do that. It's not I don't want to do a decimal. I've got the answer in front of me. It's going to be 50, but I just don't want to do a decimal one yet because I keep telling you I want exact values. So I want to do a trig version that has an exact value to it. That's really the only thing. So I'm going to make my life very easy. I'm just going to pick the sine function. Right. And we're going to do the sine function from 0 to pi upon 2. So if you imagine what that would look like, can you see that we're going from here to here, right? So the average value of this function would be this fella. Okay, I may not get what I was wanting, but that's fine. So far, so good. Can I turn this guy upside down and call him 2 over pi? And can I do this fella and what do you get if you integrate a sine? Be careful.
Minus cosine.
evaluated at 0 and at pi upon 2. Now if you plug in this guy, you get negative the cosine of pi upon 2, take away a negative, so you're going to add the cosine of 0. This is nothing, this is 1, you get 2 over pi. Now we need to solve. When is our function equal to its average value? We're trying to solve this one. Now, if I had spent a little bit more time and effort, I could probably have made this a exact answer. You know, sine of x is, you know, root 2 over 2 or something. Since I can't do that, can you tell me, because I can't avoid it, how I'm going to get the decimal version of this answer? Because it will be a decimal, it won't be an exact value.
Sine inverse of 2 over pi.
Yeah. And I'll just go to my calculator, make sure it's in radians, which I'm sure it is. And I'll do the inverse sine then of 2 over pi. And the answer I get is about 0.69. So can you imagine somewhere about there, there's a 0.69. And there's only one answer. Well, technically, aren't there an infinite number of trig answers, but isn't that the only one that's in the range 0 to pi over 2? If you wonder where the other one is, well, if there's an answer there, isn't there another answer there, and then another answer there, and another answer here, and another answer here. Just keep adding 2 pi's and pi's to everything, and you'll get all the other answers.